Okay, today we're going to go over the homework for March 15th. In class today, we started talking about, instead of just the area of algebra tiles, now we're looking at the area and perimeter. One of the things we want to remember is that we can always use colors to help us figure out the perimeter. Perimeter is the outside of the shape. So, that being said, I'm going to go through my paper and I'm going to mark with my blue highlighter all of the sides that represent 1. So this is like my toothpicks and tiles. Okay. And I'm just going to go around, make sure I get all my pieces in the blue. Next, I'm going to pick a different color and I'm going to go through and I'm going to mark all my other lines that are longer. Okay. At this point, done color coding, I'm going to count out my lines. I'm going to say, okay, how many orange lines do I have in this shape? I have 1, 2, 3, 4. Remember, each of those longer lines represents x, and x is unknown. So I have 4x plus 1, 2, 3, 4. So 4x plus 4. If I go to my next shape, again, I'm going to count the orange ones. So I have 1, so an x, 1, 2, 3, 4. So I have 4 x's plus 1, 2, 3, 4. 4 ones. My perimeter for both of these shapes is actually the same. My areas are what is different. Okay, number 2. Jack and Jill are playing a mystery game. They are trying to get 4 tiles of the same color in a row, column, or diagonally. 4 in a row wins the game. So it's like Connect 4. So part A, we need to list the coordinates of the points that they have already played as shown at right. So this is what they've already done. Jack's are the black circles, Jill's are the white circles. I'm going to start with Jill's. So I'm looking for all the white circles. So I'm going to say, okay, wait a minute. Okay, they went right 1 and up 1, 2, 3, 4, 5. So my coordinate, remember I list my x first and my y second. It's 1, 5. I've done this one so I can cross it off. Okay, actually, I'm probably not going to cross off the other ones, but the second point, she goes over 2 and up 4. So over 2, up 4. The third one, she goes over to the right 3. So it's a positive 3 and up 3. Then the next one, she goes over 4 and up 3. She has another one in that same row or column, not row, column. She goes over 4 and up 4, so it's 4, 4. The fifth one, she goes over 5. Sixth one, she goes over 5 and up 3. I'm going to do the same thing for Jack. I'm going to say, okay, his are the black circles, so he goes over 1, up 2. So 1, 2. Goes over 1, up 3. Over 1, up 1, 2, 3, 4. He then went over 2 and up 3. And then he went over 3 and up 4. Okay, I need to give 1 point to Jack and 1 point to Jill so that they would win this game. Remember, they need 4 in a row, either up and down, horizontally, or diagonally. So, for Jack, for instance, Jack is the black circle. Okay, he can go here, He could go here, or he could go here. So for Jack, the possible answers that you could write down would be 1, 1. You could write down 0, 1. Or you could write down 4, 1, 2, 3, 4, 5. Or 4, 5. Jill, I could say, okay, she has 3 right here. She could do this one. She could go to 6, 3. She could, see right here, she has 3 in a row going diagonally. She could go 0, 6. Or she could go 4, 2. Okay. Number 3, Molly and Nancy disagree about the value of the expression 2 plus 3 times 4. Molly thinks it's 20 and Nancy thinks it's 14. How could each girl have calculated her answer? Who is correct? Okay, let's look at this. So Molly thinks it's 20. Nancy thinks it's 14. So I have 2 plus 3 times 4. If I remember my order of operations, there are no parentheses, there are no exponents, but there is multiplication and division. So I do that first. 3 times 4 is 12 plus 2. Now I can do addition subtraction, which means that it does equal 14. So where is Molly getting 20? What times 4 is 20? I think to myself, oh, wait a minute. I know what she did. She added, she said 5 times 4 and it equals 20. So who is correct? Nancy is correct. She followed the order of operations. Multiplication comes before addition. Okay, moving to problem number 4. On the back. We have some numbers, some data. We need to make a box plot again. What I have already done is I have organized the data from least to greatest already because it saves me a little bit of time. It is something we have to do. Remember, it goes from least to greatest. So now I can start filling in my information. My minimum number, it's my lowest number, it's 62. My highest number is 100. Now I find my middle. So 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. I have 2 middles. Oh no. Okay. I add them together, 79 plus 80. 79 plus 80. So 159 divided by 2, 79 and a half. Okay, that's my middle. Now I want you to keep in mind my middle is in between these 2 numbers. So 79 and a half is not actually one of my data points. So when I look for my middle of my lower and upper half, I can include the 79 in my lower half, and I can include the 80 in my upper half. Okay, middles. Lower half, 1 on each end until I find the middle. I have 2. 68 plus 73 is 141 divided by 2, 70 and a half. Okay. On the upper end, again, I'm finding my middle. It's between 86 and 94. 86 plus 94 is 180 divided by 2, 90. My IQR, Q3 minus Q1, it is 90 minus 70 and a half. I have to line up my decimals. I have to borrow. 10 minus 5 is 5. My decimal, 9 minus 0, 8 minus 7. My answer is 19 and a half. Now, when we graph it, my lowest number is 62, my highest number is 100. I'm going to start with 62 down here. And I learned from my error yesterday, I'm going to count by 2s so that my numbers don't get squished. 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100, 102. Now that I have all my numbers labeled, I can start to make my graph. My 62, I draw a line above 62. I draw a line above the 100. I draw a line above the 70 and a half, the 79 and a half, and the 90. I'm going to turn my paper so I can draw these lines. I'm going to connect my middle three lines to make a box, and I'm going to connect either end. Okay, that's my box plot. It's pretty symmetrical. Okay, I do not have an outlier in this case, otherwise these whiskers would be a lot further away. It's a pretty good set of data. Number 5, find the area and perimeter of a parallelogram. So just a reminder, a parallelogram, that is 14, that's base is 14 and a half meters, and its height is 5 8/10 meters. The area for a parallelogram is base times height. Okay. Actually, I drew this incorrectly. Look at this. It doesn't give me a side length. Guess what? It's going to be a rectangle. A rectangle is a parallelogram. I'm going to say it's 14 and a half meters and 5 8/10 meters. The reason I know this is because it's asking me for the perimeter. Because it's asking me for the perimeter, I have to know the side length. It's not going to be 14 and a half. It has, because it doesn't give me all that information. It says I have the base and the height, which gives me the area. But in order to get the perimeter, I have to know all 4 sides. So anyway, area, base times height. So I have 14 and a half times 5 8/10. Okay, 8 times 5 is 40. 8 times 4 is 32 plus 4 is 36. 8 times 1 is 8, 9, 10, 11. Add a placeholder because I'm moving over to the 5. 5 times 5 is 25. 5 times 4 is 20 plus 2 is 22. 5 times 1 is 5, 6, 7. And I add them together. 0 plus 0 is 0. 6 plus 5 is 11. 2, 3, 4. 7 plus 1 is 8. I have to move my decimal 1, 2 places. So the answer is 84 and 10 meters squared. The perimeter, again, I'm going to add. So I have 14.5 plus 14.5. I'm going to do it in 2 pieces because I ran out of room because of my drawing. So 5 plus 5 is 10. 4 plus 4 is 8 plus 1 is 9. 1 plus 1 is 2. So I have 29 plus 5 and 8 tenths plus 5 and 8 tenths. 8 plus 8 is 16. 5 plus 5 is 10 plus 1 is 11. Drop my decimal. It's 11 and 6 tenths plus 29. 6 plus 0 is 6. 9 plus 1 is 10. 2 plus 1 plus 1 is 4. Drop my decimal point. My perimeter is 40 and 6 tenths meters. Problem number 6. Generic rectangles. We haven't seen these in a while. Okay. We're going to start here. I'm going to figure out my outsides before I start. So 1,600 divided by 20. I'm going to look at the 16. I'm going to look at the 2. What's 16 divided by 2? It's 8. But I have these 2 zeros. One of them's here. Okay, so that 0 makes one of those zeros, but I have to have another 0. Okay, same thing here. 56 and 8. I want to look at those. I want to say, well, what is 56 divided by 8? It is 7. There's already 0 from the 80, so it's just 27. Okay, now I can finish. So 6 times 20. 6 times 2 is 12 plus a 0. 6 times 7 is 42. So my problem is 86 times 27 equals 1,600 plus 560 plus 120 plus 42. If I do that on my side, 1,600, 560, 120, and 42. 2 plus 0 plus 0 plus 0 is 2. 6 plus 4 is 10, 11, 12. 6 plus 5 is 11, 12, 13. 1, 2. The answer is 2,322. Next generic rectangle. To figure out where I can start. I can figure this one out right away. 45 divided by 5 is 9. Okay. So I have 3,609. And I say, what is 3,600 divided by 9? I don't know about you guys. I don't know. I have to look at the 2 digits at the front and say, wait a minute. I know what 36 divided by 9 is. That's 4. But 4 times 9 is 36. It's not 3,600. But I know that this number has to be in the hundreds place value because it's the third one over. Okay, next one is 30 and 2,700. So I'm going to take 2,700 divided by 30. 27 divided by 3 is 9. One of those zeros comes from here. Another one has to come from that 9. So 90. Now I can just keep going. 30 times 400. So 3 times 4 is 12. And I add my 3 zeros. 30 times 5. 3 times 5 is 15. And a 0. 9 times 90, so 9 times 9 is 81, and I add my 0 from my 90, and now I add them all together. My multiplication problem was 495 times 39. That equals 12,000 plus 2,700 plus 150 plus 3,600 plus 810 plus 45. I'm going to add them up here. So 12,000, 2,700, 3,600, 150, 810, and 45. 5 plus 0 plus 0 plus 0 plus 0 plus 0 is 5. 5 plus 1 is 6, plus 4 is 10. 8 plus 1 is 9. Plus 6 is 15. Plus 7, so 15, 16, 17, 18, 19, 20, 21, 22. Plus 1 is 23. 2 plus 2 is 4. Plus 2 is 6. Plus 3 is 9. And 1 plus nothing is 1. The answer to 495 times 39 is 19,305. As always, if you have any questions, please do not hesitate to reach out. I would love to help you guys.